Sorry. What's wrong with it? Homework seemed pretty hard.
Yeah.
But I think the quiz is like
That formula was, I don't know.
yeah.
It just seemed
It
long.
took me a sec to get it, but
Yeah, exactly. And it's hard, like, with the guy not walking you through it, you know?
yeah.
Okay, it looks like the test is about half and half. So,
Okay.
we can.
We can start on it. So, do you understand how to find the margin of error?
Don't you just do the 90% in the applet? Right?
Are you talking about the quiz?
Yeah. Oh,
Mine
sorry.
hasn't loaded yet. I'm sorry. I'm sorry.
Plug everything into the formula,
Mm-hmm.
and you put this somewhere too.
Yes.
I know. Yeah. Well, I know. I wrote down for the margin of error. It's the times divided by the.
I'll see if I can find
N.
where you got that. Whenever you're ready, let us know.
I'm getting there. Okay. Okay. So I'm there.
So we do like this sigma over the square root of n. This is the formula. The m equals 2.
So, margin of error, we don't know.
Yeah, we do. It's 90.
Yeah, because the M formula is the one we use when they give us the margin of error. At least what I understood.
Okay. Oh, I read this wrong. So find the margin of error for a 90% confidence interval.
Okay, so that's the interval. So let me use
So
your calculator.
using the definition for m, our confidence level interval can be written as.
So we do 2 times standard deviation divided by square root of sample. Let me grab that in the calculator.
I think.
It looks right.
Yeah, I'm looking at part 4, like putting it all together.
90%. So the Z would be 1.645 for 90.
The Z.
Yeah.
So where do you plug in Z?
Because I think you just times the Z times the standard deviation divided by the square root of the sample size.
Want to try it?
Yeah, so you said Z score was what?
1.645.
And then you divide it by what?
Well, then you times it by the standard deviation divided by the square root of 25. So that would just be 5. Mm.
16.45.
It's asking us for 3 decimal places. Because, I mean, that's what I had written down from the video.
Let me see if I can find that anywhere. So do you plug it
If I
into
can
this
find it
ginormous
too.
formula?
No, I'm asking about other confidence levels.
See what you get when you plug it into here.
With the two?
Well, a confidence interval is actually a point estimate plus or minus the margin of error.
Oh, so would it be plus instead of minus? Or plus instead of multiplication?
Let's see. Maybe we can watch the video.
Mm.
Maybe we can skip it for now and we can just go to number 4.
Okay.
So I'm already looking at number 4,
Mm-hmm.
and I'm kind of looking in the book, so
Okay.
sure, expired equals.
Okay. There's a chart in the book. Is it? Oh, we know for sure that X is close to nu. So it's the third one, I think.
Or does it go the other way? It's x bar to point to
Yeah, the second one. Because like it says right here.
Yeah.
So, yeah, let's go with the second one.
Yeah.
If it's not that one, it's probably
Mm-hmm. Okay.
Okay, so this one's a 95% confidence. Standard deviation we have, size we have, and x bar. So that one, we can use the same formula that's in the book.
That big
Mhm.
one.
Okay.
So X is 526.
Trying to see. Wait. We got so the calculating the z-score, I've got 0.196. Is that correct?
For the 95%. Mm-hmm.
So let me look at or x bar.
526.
Since it's only asking us for. See, this is so hard because you can either plus it or you can minus it.
Mm-hmm.
Well, how do we pick?
Yeah. I don't know. Because, like, in the answer, she just separated it by a comma. But I don't know if you should just put one.
Mm-hmm.
See, but 7 and 8 ask for like the lower limit of the confidence interval and then the upper limit.
Oh. Okay.
So we need to look at what a point estimate. Point estimator. Here we go.
I have no idea. This was really hard.
Hmm. Okay, so we have the 95%. Um, 'cause I know I wrote, like in my notes when I watched the videos, that it was just the 1.96 times the standard deviation divided by the square root of the sample. For the margin of error. And then the lower limit and the higher limit. The lower would be subtracting and the upper would be adding with the
Okay.
long formula.
Okay, so how to calculate point estimate?
I'm gonna pull up the video.
For
do you guys?
the first,
Yeah, I'll work on getting the
for
point
number 5.
5.
Well, number 5 is just the sample mean.
Oh, so it's 526.
Yeah.
Oh, I remember
okay.
that from the video.
And then, what is the margin of error for?
So would you just put that in the applet and just grab whatever that z-score is?
Well, no, because then you take that z-score, at least what I wrote down, and times it by like the standard deviation divided by the square root of the sample size.
Give the calculator. So you would do the
1.96
1.96, right?
times what's the standard deviation?
Well,
113.
13 divided by the square root of 64.
Yeah.
So 27.65 or 685.
Yeah, that's what I got.
Okay. What is the lower limit of the confidence interval?
There we go. That's when we can do that formula that we know.
That's when we do that big long plus or minus.
Yeah. Yeah.
Okay, that makes a little bit more sense.
Where did it go?
No worries. So we are.
So let's see. Give me numbers if you go back to the test.
So.
Next bar 526.
526
minus 1.96 times standard deviation divided
113
by square root
of 64.
What did you get?
Did you do the lower first?
Yeah.
Okay, so I have 498.315.
Okay, that's what I got.
Okay, I'm not used to having these giant numbers.
I know. But then I think for the next one, you just change the plus or the minus to a plus.
So that would be 553.689 or 685. Sorry.
Yeah, that's what I got too.
Okay, and what would happen to the width of the confidence interval? I said it was decrease. Because when you grab a sample size, like the confidence isn't going to stay at 95 because you have more room. I don't know. I'm just kind of thinking of it logically.
Yeah, I know that there was like a rule about it. And I think the width of the confidence, if it increases, I think it increases. This says of the width. Oh, let me see.
Let me see. I can pull it up in the book too.
I think it decreases actually. Because I just did the same formulas, but instead of the 64 sample size, I did 90. And it started to lessen the gap between the
What
numbers,
happened
if that
between the
makes
interval
sense.
since evidence increased?
Yeah.
Okay.
It would decrease.
Yeah, so decrease is correct.
Okay.
I would, yeah.
Change to a 99%. So that would change our z-score, right?
So would it increase?
Yeah.
I would assume it would. Let me just check.
Because you have a
Yeah.
big number, you have 2.576. Ooh, I hope we're running these formulas right.
We'll find out.
For
Obviously.
So yeah, I would say it would increase.
Okay, so this one's talking about a light bulb company. We know the standard deviation. It's 400. They want a 95% confidence interval. What sample size do they need?
okay, so then that's I think another standard deviation margin error of 50 hours. Yeah, so that's when we use the n equals deviation divided by m, the margin of error, and then squared.
Okay, let me pull it up.
Where do you see that formula?
I got it from the video and I just wrote it down. So I don't know where it is in the book.
What is it really quick? So
What's
it's
the formula?
n equals
Oh, z, so parentheses z times the standard deviation divided by m, which is the margin of error, and then all of that squared.
Okay, so our z for 95,
is 1.
1.96 times by standard deviation, right?
Yeah. Divided by 50.
50 and then squared. So 0.31. Oh wait, maybe I did that wrong.
Yeah, because you only squared the 50.
Oops.
So you need to put that whole thing in parentheses. There we go.
So 245.86.
So it'd be 246.
Mm-hmm.
What you got?
Yeah, should run the whole number.
Yeah.
And this is asking
Oh, we're just doing more confidence intervals.
Okay.
so these are doing the plus and minus formulas. It's asking for the upper and lower.
Yeah. Okay.
So plug all this into the formula.
I think so, yeah.
There's just a lot. There's like a lot of numbers in here I don't think we need.
Mm-hmm. Yeah.
Okay, so I can give you the numbers if you want to plug it in the formula.
Oh, let's see. We don't have X barred.
Well, wouldn't that be the 1100 or the?
Oh yeah, we do. Good eye.
Yeah. Okay. Okay.
You're not crazy. It's there.
Sorry, I've worked way too much today.
You're good.
95%.
We just gotta pray she does another test review.
Mm. Mm.
Sample size.
36.
Okay, so I have 99,001.53 repeating.
Yeah, that's what I got.
guess we can try it.
So it's rounding to the nearest whole number, so we'll just go 99002. And then
Change that.
Then what's the upper? So
now we just plus it,
plus it.
which would be
100
22,998.
You would round no.
No.
Well, I guess that bumps that to
Oh,
a 5.
yep. So 9 at the end.
Would it be
So 122,999.
999? Do you ever in that was your
Okay.
homework, learning how to read big numbers like that?
Yeah,
I
that was
wish.
easy homework, right?
Okay, and 14. I would say all.
I would say all as well.
Yeah, because there's 3 requirements.
Okay,
Okay, what one did we skip?
3.
Number
No.
3.
We should be able to get this, guys, now after we did the whole thing.
I kept the old answer we had, which is 16.45, but
See.
you can
So
try it.
Yeah. I'll go and I'll run it again.
Okay. Yeah, we can do that
I
too.
feel like this one should be probably the easiest one for us to get.
Oh, so it's right. So here's the. It has to be that formula. The 2.
Yeah.
Standard deviation divided by square root of
Okay,
n.
I'll submit it first, guys. We'll see where we're at.
Okay.
Good luck. We like miss all of them. We have to start all over. I think I'd cry.
I know.
I'd go to Taco Bell. Guys, we got 100%.
We got 100%. It's a miracle.
Guys, that was the first time that
Sweet.
ever happened.
Sweet.
We should celebrate. And
Cool.
that's,
Cool.
I'm gonna cry. I'm so
Awesome.
happy.
That was the shortest
Wait, so the first one,
I know.
so number 3 was the 16.45.
Uh-huh.
16.45.
Oh, this class is gonna make me go insane. Okay, well, see you on
Thanks,
Thursday.
Jensen.
Okay. Bye, guys.